Good afternoon, grade 12s, or good morning, depending when you do this. We're moving on to some exam time questions now of analytical geometry. And as you know, the exam is a section A and a section B. So I'm going to do one example here that came out of a section A, and then what I'll do is the next little video, which is just the picture, will be an example from section B at a level that is a little bit more difficult. So this is a typical section A example of analytical geometry. So let's set the scene here. We start with given that the circle is x squared plus y squared equals r squared. So you know now from your notes that this is a circle with the center, the origin, 0, 0, and the radius obviously would be the same all the way around. And they give you the point T, which is 4, -6, and they tell us that it's a midpoint. So T is going to be the point 4 minus 6. And like geometry, analytical geometry is also very visual, so it's useful to put everything on the sketch and it kind of jumps out at you a little bit later when you're looking at the questions. And then our 3 questions here. The first one is to find angle OTR. Now let's have a look at that. So OTR is going to be this angle here. And if we look at that angle, something should be reminding us going to a completely different section of work. If you think back to circle geometry from last year, that's where this little fact is going to come from. And I like this question because it integrates circle geometry with analytical geometry. We need to start looking out for this at now point, like the interlinking of the sections, even sometimes using trig in these type of examples as well. So we need to find the size of OTR, and I think you're all happy with the fact that that would be 90 degrees because it's an angle from the center of a circle bisects the chord at 90 degrees. So that's the reason why OTR would be 90 degrees. Second question, we need to find, or we need to prove that the equation of PR is 3y equals 2x minus 26. So we need to find that we need to prove that the equation of this line here is in fact that there. So we step back and we have a look and we think, okay, well, if I know that's 90, in analytical geometry, immediately I'll then know that my gradients, the product of the gradients is -1. So if we need to find this line here, remember we have our standard equation y equals mx plus c, and we need a gradient and a random point xy. So we have our random point xy, there it is, 4, -6, because it lies on the line PR. And the second thing we need is the gradient of PR. We don't have the gradient of PR, but we can find the gradient of OT. We can find the gradient of OT because we've got the origin 0, 0, and we've got the point T. So we find the gradient of OT, and then it's easy to find the gradient of PR because they're perpendicular. So once we've got the random point and the gradient, we can then find the equation of the straight line. That's number 2 done. So we've done 1 and we've done 2. Now let's look at 3. The third thing we need to do is find the radius of the circle. Now the radius of the circle would be here, here, here. So we need any one of those lengths. And the obvious one here would be R, because T is not helpful. It doesn't lie on the circle. P is helpful, but we don't actually have that point yet. We could find it out, but we don't have it. So we're going to use R. Now if we look at in the previous one, we found the equation of that line. So if we can find the equation of that line, we can find R. Because R is going to be an x-intercept, so we make y0 solve for x. Then once we've got that point there, we will know the radius, because the radius will be from the center to whatever that x value is there. Okay, so this is just one little example. It's one of the examples I've asked you to do. It's in the notes with a memo, but this is just an approach. and a more visual approach. And then I'm going to do another question from section B, upper level, but also still very doable. The nice thing about this section is that it takes a whole lot of knowledge that is quite simple and it's to apply it in different scenarios. And the more scenarios you have and you see, the better equipped you will be. So good luck. Thanks, grade 12. On to the next example. Okay, grade 12, so now we continue with a question from section B. We talk about in the diagram below, circle center P touches the x-axis. So there we go, it touches the x-axis over there. We also have that BO, this length here, is going to be 2 times OE, so it's double its length. So let's call it something so that stands out at us. If that's length x, then this length is going to be 2x. It's going to be double in length. We also have the fact that A, 10 root 5 minus 1 is on the circle. So that point there, let's take it and show it up here. It's going to be 10 root 5 minus 1. They also say that the radius of the circle is root 5 units. So that length there is going to be root 5. Let's just fill it in here as well. So both of those are going to be root 5. That's the radius of my circle. And then lastly, BAE is a tangent at A with E on the x-axis. Now, I always just like to write that, whether it's circle geometry or analytical geometry, to remind ourselves that that's a tangent. Now, before we go on to the actual questions, let's just fill in some other facts. If this here was a tangent, then this is going to be 90 degrees. Remember, tangent with a circle, and then in fact that would also be 90 degrees over there. Now, let's have a look at some of the questions. Okay, our first question here, determine the equation of the straight line going through A and P. So we want to determine the equation of the straight line through A and P. Now we always go back to our basics. If we want to determine the equation of the straight line, we've got our standard equation, y equals mx plus c, and we need our gradient and we need our random point. So that is what we need to find the equation of this straight line AP. Now we have A, right? Because A was given to us, so we have our random point. It's going to be root 10, sorry, not root 10, 10 root 5 minus 1. So that's going to be the random point. And the second thing that we need to now go and look for is a gradient of this line here. Now, let's think a little bit. We've got point A, but we don't have point P. But we do have the fact that that is 90 degrees over there, which means that if I can find the gradient of this line here, BE, then because of that 90 degrees, I can find the gradient of line AP. Now, if I look directly at BE, I don't have the gradient of that line. I don't have the point B, I don't have the point E, but I do have a fact here that is very useful. I have the fact that BO is double the length of OE. So if I think about my formula for gradient, which is change in y, y2 minus y1, over change in x, which is x2 minus x1, I've got a very useful fact that I can use here. The fact that the change in y on the y-axis is 2x over the change on the x-axis is 2 means that the gradient of this line here is 2. But, oh, don't forget that's a negative. It's a negative gradient because it's sloping in that direction. So in fact, the gradient is not 2, it's minus 2. So we use the fact here that the one is double the other, the y is double the x, the gradient is 2, but it's negative 2 because of the slope. And then the gradient of the line that I'm looking for over here will then be the inverse. So 2 over 1 becomes 1 over 2, and it's going to be positive. So there, I've got all that I need now to go and find the equation of the straight line through A and P. So that's A done. Tick. Now we'll go and have a look at B. Now for number B, it says hence calculate the coordinates of P. Hence means building on what we've already found out in number A. So hence calculate the coordinates of P. P is going to be the center of the circle and it has the coordinates x and y. So essentially we're looking for x and for y. Now x is unknown, but y is not unknown. Can you see that? Because we don't know this value here, which is going to be x, but we do know the y, don't we? The y is just going to be the radius. It's going to be root 5. So we don't know the x, but we know the y. But we also know the equation of line AP because we've just found it in part A. So if we know the equation of the line through AP, so y equals mx plus c, we've worked out what that full equation is. And if I want to substitute the point x root 5, where I've got 5, but I don't know what x is, I sub in the point x and the point root 5, and then I will be able to find out what x is equal to, and then I have found out points p, x, and y. Okay, I hope you understand the theory of what I've just explained. Go and try it on your own now, but I've explained the theory. And then we're going to move on to the last one, C, which if you'll notice there, it's out of 8 marks. So that's going to require quite a bit of working. Okay, grade 12. So with number C here, we need to determine the size of ABP, angle ABP, which is sitting, it's got a nice bright color, sitting over there, angle ABP. So now, I think one of the first things to remind ourselves is we're going to probably be dealing with, no, not that. What we're going to be dealing with is this, tan of an angle equal to a gradient. So remember, the angle of inclination is always going to be that angle there, and it's the angle that a line makes with the x-axis going anti-clockwise, and it's always equal to the gradient. So I'm pretty sure we're going to be using that somewhere. Now, the angle I'm looking for is sitting up in the sky. So it's not going to be a direct angle of inclination. It's going to require quite a bit of working to find that angle. Now let's look at what we've done, what we've got before. We found the equation of the line AP in part A, and then in part B, we found the coordinates of P, which were x and root 5. X we found out, it'll be on the memo. So now we have a look and we think, okay, in terms of the big picture, and it's always useful to have a working plan first. In the big picture, if we've got the equation of this line here, or the gradient of that line, I can find that angle there. And that angle there is going to be very useful, because if I can now somehow find the equation of this angle here, can you see what's happening? I've got the equation of a, sorry, not the equation, I've got the exterior angle of a triangle equal to the two interior opposites. So what I have indeed here is that this is my exterior angle, and it will be equal to that one there plus that one there. So if I'm looking for ABP, this one here, it's going to be the exterior angle minus this one here. So now I need to think of a strategy to go and find those two angles. Now, this angle here is manageable because we already know that this gradient of this line here is going to be -2. So if the gradient is -2, I can go and find that angle there using tan of the angle equals -2. And remember, because it's an obtuse angle bigger than 180, we're going to go and work out what that angle is. It's going to be 180 minus. And remember, to find the acute angle, all these little reminders here, we've got to go shift tan 2 on our calculator. Not shift tan minus 2, shift tan 2. The minus just indicates that it's in the second quadrant. So it's 180 minus, and we go and work that angle out, and I've got my first little angle. Now, the next angle to find is going to be this angle here. So now we need the gradient of this line here. It's looking a bit messy, sorry, but if you can stay focused. We're looking for the equation of line B. Let's use a highlighter. We're looking for the equation of this line here, BP. Now, we have point P. We don't have the gradient of that line, but we can go and find out a few things, okay? I wonder if we could find out the point B. Let's have a look. So we're thinking, can we find out? Let's see what we've got. I wonder if we can find the equation of this line. If we can go and find the equation of the line BE. Let's think of that. The equation of the straight line BE, I need a gradient and I need a random point. Yes, do I have the gradient? It's -2. Do I have a random point? Yes, I do. It's point A. It was given. There it is there. So therefore, I can go and find the equation of line BE. Yes, I can do that. So I've got the equation of line BE. So if I have the equation of line BE, can I not go and find point B, which is going to be the y-intercept? Yes, I can. So now I have point B, tick, and I have point P, tick. I can then go and find the gradient of the line BP. Absolutely. So if I can find the equation of line BP, I would then have found that angle there because of tan of an angle equal to a gradient. So then I found the angle there. So now we're back to the point, if I have that angle minus that angle there, I can find the equation of the angle that I'm looking for, which is going to be ABP. Now, grade 12s, I apologize for the messiness of this little video, but hopefully you followed the logic involved in those 8 marks there quite a lot, and I've written it all out. It's in the memo. So go and have a look now, step by step, of how it's done. If you struggle to follow, maybe go back and have a look at this video again. It's not very long, especially just the C part. Okay, good luck. Thanks, grade 12s. Bye.